So to practice for the final, here's the question. Let's say there's 20 of you in here, and I'm going to choose out groups of 3. How many groups could I pick? I'm going to have you use your calculator to solve this one. Okay, if you forgot where this is, you put in the 20 first, and then you go to math, the math key, and then you arrow over to probability, PRB in some calculators, or PROB. So math, and then probability, and then it's NCR. So you go down and you hit that, and you got to put in the other number, which is 3. And 20C3 comes out to 1140. There's a lot of ways I could get groups of 3 out of this. This is this room. This is you guys. If I say you guys are a group of 3, do you get that I could get over 1,000 different groups of 3? And this doesn't even have the order mattering. If the order mattered, then what would I have used? A P. Everybody find the same thing except it's 20P3. If the problem says that the order matters, like one that a lot of times people forget that the order matters is books on a shelf. If you have 20 books and you pull out 3 at a time, but if you just say there's 20 books on a shelf, does the order matter? Well, yeah. If you move a book, the order is different. So then it's a P question if it's books on a shelf. You want to do this? Thank you. All right. So Rena, 20P3 with your calculator. Got it? What'd you get?
6,840.
And why is there more? Because the order matters. If I pick that group of 3, like it's you 3 kids over there. If I keep you in the order you're in, where you're closest to the door and you're second closest and you're third, then I could rearrange you and then rearrange you and rearrange you, and that's why you get more orders. Okay. So that's one thing that your calculator would be good for. Here's another one where your calculator would really, really help, and it's to make a box plot. I am going to tell you the data, and I want you all to put it in. This is under Stat Edit. So everybody can go there right now, Stat Edit. And if there's any numbers there, just hit the delete key, DEL, until they're gone, and then put in 20, 25, 28, 29, 50. If you put those into the list 1, if you're having trouble, ask me now. You can't ask me on the test how to do this, but you could ask me today. Put it in list 1, and then you'll be able to find the 5-number summary. Don't forget that you have to arrow down on your calculator. Find those 5 numbers. All right, did you guys get that the smallest number was 20, and that just makes sense. I can even see that right there. And then 22.5 went here. The middle number that's in here somewhere is 28. The Q3 is this end of the box. That's 39.5. And then the max is 50. There. Now, here's a follow-up question you'd have to be able to answer. How much of the data is between 20 and 22.5? 25%, and that's the key, is do you know that each of these things, like this has 25% of the data between there and there? This red bar like between 22.5 and 28, that has 25% of the data. That has 25% of the data. And that has 25% of the data. I couldn't believe when we gave the test on this and we said, like, how much is between 22.5 and 39.5, like the two ends of the box? Everybody's answers were all over the place. So let me ask you again. How much percent of our data is between 22.5, right here, and 39.5, right there? What percent is between those two? 50. 25 for this part, and 25 for this part. Now, what I think kids were getting confused about is when we give you this other thing, which is completely different. This is called the bell curve. And we give you those stats like there's 34 here and there's 34 here. I think people were thinking it was like that, where it was adding up 34 and 34 and saying there's 68%. Well, that's between one standard deviation this way and one standard deviation that way. So let me give you an example. Let's say that our data had 100 here, because that's IQs. You remember doing this one before? And this is 115, and this would be 85. Then what percent of the kids, let's just make one more. If I go out one more standard deviation, this will be to 130. That gets to be a really smart kid. 2 standard deviations above normal, see? And then this number here is 13.5. We'll give you these. What if I said, what percent of kids are between 85 IQ to 130 IQ? What percent of kids are in there? What percent of kids have between an 85 and 130 IQ? Cooper, what do you think we should add up?
All the numbers.
So,
34 and 13.5.
yep. Got it done yet?
Wouldn't it be like 81.5?
I think that's right. Anybody else get 81.5? Yeah. All right, 81.5% of the kids. Does that mean all the other kids are above that? Nope. That means some of the kids are below it and some of the kids are above it. But 81.5% of the people were in those zones. All right. Next thing is, if my class, Mr. Server's class, has a 5 standard deviation, and Mr. Lewis's class has a 10 standard deviation, what does that even mean? You can say something about my scores. Can you say if my scores are better or not? No, you can't. So you'd have to be able to explain what's the difference between mine's 5, his is 10. What does that even mean? And it's not about mine are better than his, or that his are better than mine. All right. This is the part where you guys have been doing a lot of just sitting there. I want you to actually talk to somebody. So, you three, you guys straight across from each other. Talk to them. What do you think is the right answer for this? How do you describe the difference? I'll pause for a second while you talk to the person next to you. All right, so I heard some good answers out there. So when these guys deviate more, I can't really argue that you're right, they deviate more, but you'd have to tell me more than that, which means that they're more spread apart. And these kids were more close together. So their scores weren't that far from average. They were all pretty close in that class. Here, they were more spread out. Some kids were really low, some kids were really high. Okay, so that's what when you talk about this, talk about spread out. More spread out, less spread out would be a good way to describe that. Okay, next one. It's been a while since we did this. Let's say I asked you to graph 4 to the x. I'd be like, I don't remember what that looks like at all. But do you remember what an XY chart is and how to find a bunch of points? Because if you can find me 3 points on this, maybe 4, you'll be able to tell where the graph goes. So just find me 3 or 4 points that would be on the chart. You can pick any number, starting number you want. Don't torture yourself. Pick easy starting numbers, but try to see if you can get 3 points that would be on this graph. So the kids that are still sitting there, here's a reminder. You can put in x's anything you want. So put it in x is 0, x is 1, x is 2, maybe put in -1 and see what you get, and then you'll have a point. 0 comma something is a point on this graph.
How many points is it?
You'd want at a minimum 3 because it's a curve. The test would have to tell you how many you'd have to make, but let's do 3 in this case. Okay, let's see if you got a few points right. When you stuck in 0, a lot of people think 4 to the 0 is 0, but it is not. What is 4 to the 0? When I do this, what do you get? Anything to the 0 power is not 0. It's 1. Can you remove? Thank you. And if I put in a 1, Victoria, what do you get when you put 4 to the 1? 4 is correct. How about if I put it to the 2?
16.
Good. What if I put it to the -1? This is a critical one. You got to know what happens when you have a negative power. What does that do again?
I meant this one. 0.2.
It ends up flipping it. So 4 turns into 1/4. Don't forget that. If you were going to be like lost on that, put this point on your list. -1 power makes the thing flip. 4 turns into 1/4. Because like 4 is like 4 over 1. So it's flipping it over to 1/4. Okay. And then if you graphed this, you would see that it kind of looks like this because that's what exponentials look like. If you actually graphed all of those points. And this is probably even not steep enough. Probably you'd go even steeper than that. Okay, so what else do we have to know? Man, so many things. If I say this, u1 equals 3, un equals un minus 1, parentheses 4. Do you remember what that means? If you do, you should be able to tell me the first 3 numbers on the list. Pause for a second. Give that one a try. Okay, if you knew what was going on, you knew it started with 3. And then this 4 here is in parentheses, which means times by 4. You have a calculator. 4 times 3 isn't any problem, but 12 times the 4 might have been a problem for you. 48. Raise your hand if you had those right. Okay, cool. Now, if I had gone the other way, would you have been able to take this and write it like this? You know what I mean? Could you make the formula for it? The weirdest part is this part right here, and a ton of kids got that wrong on the test. U sub n equals U sub n minus 1. Everybody knows that it's times 4, so everybody had that, but tons of people did not have the pink part. All right. Next up is factoring. There will be more than one chance to factor on the test, but imagine this question was in play. X squared minus 4x minus 5 divided by, so you get that all factored and then it'll work a lot nicer. So step number 1, if you can't factor, you'd be toast on this problem. So hopefully you can factor that. Step 2, do you remember that divide actually means flip that second part? Remember how this part here can get flipped? All right, see if you can do it. I'll pause for a second and give that a shot. Okay, if you either you know how to factor this or you don't by now. You put an X here and an X here. Then I say it's a 3-step process. Then you got to figure out if it's pluses or minuses or one of each. And I look at this, and the key one is really this. If there's a negative there, then you have to have one positive and one negative. Okay. There's more complicated rules than just that. But now, since that is negative right there, I need one of the numbers to be negative and one positive. So I'm going to use 5 and 1. That's going to be a 5 and that's going to be a 1. How do I know I did it right? Because you can multiply it all out. First, x squared. Outside negative 5x. Inside 1x. And negative 5 and 1x makes negative 4x, which is what we wanted. So there, it's factored. Can it be done? No, because the divide changes to a times. And this part flips. X minus 5 on the bottom. That's why that's there. So that this can cancel this. And if you can just go, how do I do 14 times that and divide it by 7 correctly, you'll have it. I'm going to give you another second. There's another cancel you can do. I hope you caught it. Because if you leave a 14 in your answer, you get it wrong. Who noticed that the 14 has a 2 times 7 in it? Raise your hand if you caught that. Okay, good. So if that is true, what's good about it is that the 7 cancels the 7, and now it's just a 2 left, times x plus 1. I'd be fine with you leaving it like this, or multiplying it out and saying 2x plus 2. Either one of those two answers. Need to be honest here, so I know if we should practice another one or not. How many of you had that? One of those two exact answers. You had it perfect. It's not many people. We should try another one like that. Okay, this will be just like that last one. Ready? X squared plus 7x minus 8. Oh, yep, that works. Nope, it doesn't. My bad. No, wait, that would have worked. That will work. My bad. Okay, that over x minus or plus 8 there divided by 2 over 6. My favorite saying, it's even written on the wall because a kid put it in a poster this year, is if you can factor it, you should. And so, this can be factored. But a lot of people don't even notice that the 6 also can get factored. Aben, can you tell me either one of those factorings?
6 would be 2 and 3.
Perfect. Why is that good? Because what cancels now? The 6 does cancel and becomes 2 times 3. You're right. But what I mean is we made it into a 2 times 3, so it would cancel the other 2. So those cancel, and they're gone. And now this part factors. Christian, you got that part factored into 2 parentheses? Excellent. What'd you get?
X
Minus 8 and plus 1. Very good. And on the bottom, we still have x plus 8. That's just a copy down from here to there. And nothing cancels. Dang. This is still as a 1 over a 3. So if I'm changing divided by 1/3, I'd change it to times by 3 over 1. And I intended for something to cancel here. What do you think I thought was going to cancel? The 8s. But I made it, it's messed up because you can't cancel it when there's a plus and there's a minus. So I have to leave it just like that and you'd be done. The real test question would have like these canceling. But I goofed and then I made the problem. Yes?
Why is that x minus 8 and not x plus 8 and x minus 1? Because it's a positive 7.
Oh my gosh, you are correct. That's why it actually does cancel. It's x plus 8 and x minus 1. Thank you for catching that. I don't know if it was a kid that I asked for the answer that goofed it up, or me not checking their answer, or I heard them wrong, or whatever. But you're right. It should have been this. I never took the time to check it. Let me just double check it now. Positive 8x minus 1x makes positive 7x. You are correct. Good catch. Then those cancel. And now I can actually get the final answer. It's either 3 parentheses x minus 1, because I say if you can factor it, you should. Or you can multiply that in and get 3x minus 3. Either one of those two answers is good. All right, I think we've practiced that enough. Now, what if I said 2 to the x was a function? Would you agree that that looks like an exponential function? What if I said plus 4 here? A lot of you know it's going to move 4, but which way is it going to move? Is that 4 up, or is it 4 down? Or is it 4 left, or is it 4 to the right? I want you to point which way you think it should move. Like, do you think it should move up? Do you think it should be right? Do you think it should be left? Do you think it should be down? Just point which way you think it should go. Almost everybody is pointing left, and you are correct. Left 4. It goes to the left 4. Because it's inside. And do you remember those deals horizontal on inside? So that was a horizontal move. If it had been on the outside, like here, plus 8, that would have gone up 8. All right. Now, this is exponential, but it doesn't have a starting value. If I did have a starting value, I would have put it in front, like here. Let's say I wanted to start with $100. I would have squeezed it in the front like that. So, can you give me an equation for this? Start at 10 and grow 20%. Well, I'd say start with y equals, well, I know there's got to be a 10 in it. Can you do the rest? Can you write me the equation that starts at 10 and grows 20%? Hint, if it's an exponential, it has an x in the exponent. That's the point of exponentials. Aha! Take that, put it up in the phone jail up there. You can have it back at the end of the arc. Aurelia, tell me, what do you think has to go here? It's the hardest part. Picking on you because you're smart. If I just have 0.2, it'll shrink.
Would it be 1.2?
1 plus the 0.2, you are correct. 1.2 or 1 plus 0.2. Either way works. That's 20% growth. There's an x in the exponent here, which is where you put your time. Nobody told me the time, so I don't know. But the starting value always goes in the front, right there. I'll give you one more like that. Should be easy. Jim's got 8 head of cattle. He's actually raising cows. People actually do this. I know somebody. Raises cows. Makes good money. Sells the cows when they're old enough to be butchered. You got to be able to handle the fact that your cow is not going to live forever. So you got to be pretty tough about that in your head. So anyway, this person raises cows. He starts with 10, and he has a bad year where he's losing 10% of his stock each year because, like, I don't know, maybe they're just not healthy, or maybe he's harvesting them, or whatever it is, but he starts with 10, goes down 10%. 10 goes down 10%. 1 minus 0.10. Do you see how that's going down 10%? You see how it's starting with 10? Okay. So that's a little bit on exponentials. So there's a whole lot more than what I've just done with you, but we've done a little bit of practice on a lot of these things. I guess if I could leave you with just one last thing, it would probably be this. If I had this, would you know what the x-intercepts are? And, oh, wait, let's just put in one more. would you know the x-intercepts and would you know how to sketch this thing? If you've forgotten this, I'll help you right now. You just got to pay attention. That's an equation. The x-intercepts are basically sitting there, but you just got to be careful that you don't by accident think that the x-intercepts are 3 and -4 and -7, because they're not. The x-intercepts are -3, +4, and +7. So here's one at -3, here's one at 4, and here's one at 7. But do you remember how to make the rest of the graph? Remember? Cool. Tell me about the right end or the left end, or where do you want to start?
So, isn't it when it's like odd, it bounces?
It is odd, yes, because if we multiply this all out, it would be x to the third. And so there's a, and each of these things is a little power of 1. So the lead term is x to the third. That's a really good point. And these powers matter too, but they're all 1s, which just means it's going to pass through it. If they had been 2s, they would have bounced. All right, so do you know the right end, up or down? Do you remember that deal?
Up,
It's up. Why?
because the leading term is positive.
Because that's a positive number. There wasn't any negatives here or here or here in the front. Then that's positive, which means it's going up right here. It has to go through there, and then through there, and then through there. You guys remember that? Now that you see it, do you remember what's going on there? Okay, yes.
When is it that the left side would end up? If it was like that, if the exponent was 2, would it go up, or?
If the lead term's power is odd, they'll be always going the opposite direction as each other. If that lead term, like for a different one, if I had like 7x to the 12th and it turned out even like that, then this is the only one that really matters. Since the lead term's positive, it'd be up on the right. Since that's even, it would be bouncing there. And both, sorry, there could be a bounce in it, my bad. The other thing that you asked about was the ends. This end and this end would not be going the opposite direction. They'd be going the same direction. So this even power means same direction. Okay. Those should help you do better on the final. I want to leave a bunch of time left at the end for you guys to ask me individual questions. Don't forget that that this packet is got to be turned in, and it's worth a bunch of points. Heck, the key is sitting right there. If you can't take a practice packet and a key and work out how to get good answers there for me, then you're just not trying. And that's how I use the packet. Because if you're not trying, why would I give you any kind of a break at the end of the semester and I'm trying to decide which grade to give you? You're not even going to do the review for the final. Why should I give you any kind of a break? Okay, so strongly encourage you to get that done, turned in. And if you have any more individual questions, come on up. Last thought for this hour, for 4th hour, we have it on the 2nd day of final. So not tomorrow, but the next day. All right, and it's in the second half of the day, after lunch, basically. All right, that's all I got for you for today.